everyone. So the last video, hopefully, of this section, part 1 of drilling. So primary design consideration for your drill pipe. So you want to have a drill pipe that is very well made and can do the functionality that you are expecting from it to do, but you need to design it. So in order to design it, your drill pipe will be under significant actual loading. For example, consider that you have piece of pipes right all the way down hole, and then let's say this is 10,000 feet, and the weight of this drill pipe is 24, let's say, pound per feet, right? So this drill pipe will have a weight of 24,000 pound force, right? So that's a huge weight, right? So there are significant tension in the pipe, especially near the surface, right? So you need to design your casing based on the tension, based on the, sorry about that. Okay, cool. Based on the tension, based on the compression, based on the torsion load, burst pressure. Burst pressure means that you have huge pressure inside but no pressure outside, so that causes burst of the pipe, right? Collapse pressure, again, collapse means that high pressure outside and no pressure inside, so you will have a collapse of the drill pipe. Fatigue loading, corrosion, abrasion, these are all the design factors that you would need to consider. We don't go into the details of these designs. You will learn more about them in drilling engineering course. Now, another thing that you need to consider when you drill a wellbore is running casing. So what is casing? So consider that, let me add a new slide here so we can draw something for you guys. All right, so look here. So let's say you drilled 2,000 feet, right, down with some drill bit, right? And then you want to continue drilling, right? So here, there are formations that are freshwater formation, so you want to protect them, right? In order to do that, you put a piece of pipe inside the wellbore, which is called casing, and then you inject cement into the wellbore, and this cement will go here, will go to the annulus and fill the annulus. And then you wait until this cement is set. So you have a piece of pipe here, which basically prevents the communication between your wellbore and all other formations there, right? This is called casing. Casing is beneficial in many ways. One is protecting the formations underground. It helps the integrity of the wellbore. It prevents the caving of these formations. As you go deeper, you may hit some formation that are unconsolidated and they may cave into the wellbore. So casing basically prevents these things happen. So it's basically improves the well integrity. So then you continue your drilling, right? Of course, your diameter have reduced, right? The next section, and then you hit a formation that, let's say, it's very high pressure. So you don't wanna touch that formation, right? You don't want to deal with that. So you want to have another casing set into the wellbore, and then again inject cement and then fill the annulus between your wellbore and the outer diameter of the casing, right? That casing will be set there, and then you continue again, set another casing, sorry, not this way, from here all the way down, right? And then cement, and then cement, right? So this is how your well look like. Actually, there are multiple casing. Your well size reduces as you go down, and these formations are basically isolated from your wellbore using the casing and cementing process that you do. Okay, so it has both environmental benefits and also the integrity of your formation. Now, if your oil and gas are coming out of the wellbore, then there is no connection between your hydrocarbons and other formations that are there passing through, right? So this is the benefit of having a casing, and all the wellbores currently drilled, they have casings, and that's what I wanted to talk about it here. There are many basically factors that affect your drilling operation, characteristics of the rock which you must be drilled. So you might have a soft formation, you might have a hard formation, you may want to change your drill bit based on that. You change the rotation speed, change the weight on bit. All these factors play a role on your drilling. Subsurface fluid pressure, so you might use a high density drilling fluid, you might need to use a low density drilling fluid, and that only depends on what is the formation pressures that you are drilling through. So usually as you go down, the pressure inside these formations increases linearly, usually if you have a normal pressure gradient, and based on that, your hydrostatic of drilling fluid inside the wellbore should basically be higher than the pressures of the formation that you are drilling through. So you might need to change the density of your mud to increase the hydrostatic pressure at the bottom. Fluid temperature containment, if you have H2S, you need to do some extra work to do a safe operation, and physical orientation of subsurface rocks, of course, that's also an important parameter. Now drill bits, there are different drill bits that used for different formation. Again, I mentioned you have to change your drill bit maybe depending on the formation, rotary speed, bit weight, and fluid system. All these four I mentioned in the previous slide as well. Drill bits comes into different formats. There are PDC bits, diamond bits, mild tooth, junk mill boot, diamond core bit. Different types of drill bits are used for different formation, but I'm not going to go into the details of these drill bits, but we will discuss them later on in drilling fluid engineering. But each of these drill bits are good for different types of formation that you are drilling through, and depending on what depths you are drilling, what type of formation you are drilling, you would need to change your type of drill bit as well. Also, you need to consider the economic of that as well. Core samples we talked about. These are typical core samples that are drilled. Some of these drill bits can be used for coring. If you look at, for example, this one, diamond core bit, it has a hollow space in the middle, and as you drill, it basically can take out a cylinder, a core sample of the reservoir, and bring it to the surface. Okay, so these are the core samples, for example, that can be taken, and these cores go to the laboratory, for example, in the rock fluid properties laboratory that we have next semester, and they will be analyzed for their porosity, permeability, and other properties. So they come with different size. You would need different sizes, of course, right? So the PDC bit works this way. It applies the force directional onto the formation. Diamonds are very strong because they will not really break easily, and rotary cone is basically by applying a normal force to the underground formation and crack the rock. So these are basically the main cutting mechanism of these bits. PDC bits, there are many. There is no moving part really. All these are a single part, and the whole thing moves together, and they are really strong and resistant to the force that being applied to them. Window milling bits, these are the window milling bits. There are different types of them. You can see we're not gonna go into more details really here. And the bit cone, can check that out, some picture of the drill bits. This is the drill bit nozzles. Again, that's where the drilling fluid comes out and removes the cutting at the bottom, and then it takes it to the surface. Okay, so really high pressure injection happens when you have a drill bit. So there are different drill bit sizes you can see here. So starting from very small to very large, depending on where you are drilling. So remember, the way the wellbore look like is something like this. You would need smaller drill bits as you go down. So Compressive strengths of the drill bit also important, and the rocks, depending on what type of rock you're drilling, you would need to use different types of rock. These are just different types of rocks. So it's the purpose of this picture is just to tell you that different rocks might have different compressive strengths. It means that you need to apply more force to them to be able to drill them. Quartz, basically one of the hardest ones, and then chalk is kind of the easiest one that you can drill through. And kind of numbers to give you an idea of the normal weight and rotary speeds. So you can see that the weight on beat, kind of pound force per inch, that's the normal value, 3000 to 5000. Maybe some formation, some basically other drill bits you can apply more force. 6,000 to 8,000 pound force per inch, and also the rotary speed that you can use for them is basically rotation per minute, and this is the speed that you can rotate them. Kind of give you an idea of what how the numbers look like. We'll continue this topic next week, and that would be drilling part 2. Thank you.